Thank you for this opportunity and for me and for BBI. My name again is Hafdi Salah. I'm a managing partner in BBI. We're a system integrator specialized and focused on data management as a global player in the region and worldwide. I'll go ahead with the presentation. See if I'm allowed to do that right now. It's all coming in the screen?
Yes, it's perfect.
Great, thank you. So let me just put that screen here, down here. Thank you again, Nizam. So I'll be talking about the best practices that we need to adopt or follow for the cloud modernization data warehouse. Let me remove the comment and the subtitles here also, because yeah, that's perfect. Great. So I'll be talking about the best practices for cloud modernization. We talk about data warehouse and talking about data lake also, because that's really important to mix and match between the two. And we try to be specific to the government sector, but some common practices that are in government sector can be also true and feasible for different sectors like banking, I would say, financial services, telecoms also. Before moving into the core subjects of the presentation, I will try to cover very quickly the basics, really what is cloud, what is hybrid, what is a data warehouse traditional compared to the modern and data lake and so on. And then we go into the core subject of the best practices, okay? So when we talk about modern and we talk moving really, so initially we all have been in the premises and then we start talking about this on cloud. On cloud can be in multiple models. So on-prem really traditional companies, enterprises, business users have their own data centers really practically, where they have their own hardwares, they support their own hardwares, they put their own networks, they put their own cables. Sometimes the building, the data center itself is a leased place, but they still have to manage themselves, the hardware they have to have the specialized people in, as a system administrator, as OS specialist, as a network specialist, and so on. So they had to cover all that for themselves. And also when they are on-prem, since they own the whole setup and the whole hardware and also the business application, they have to manage the upgrades, they have to manage the obsolete, they have to do the migration from an old system to a new system. And sometimes even here, when we talk about the Middle East, the challenge we had on-prem is you own the hardware. So sometimes you have to go and import it from outside the country, from Europe or from the US or from Asia where it's manufactured. And that was really big hassle and customs, clearance from the airport, from the port. And I can tell you some cases where after the clearance from the customs, the hardware came into the data center and became almost obsolete. So you can understand that that's really, really big challenge. And when the cloud came in, that was really opening up for a lot of people to scale up and really adopt that cloud. But again, the cloud has its own challenges also, which we'll talk about it. So on cloud, it really means is you don't own this hardware, you don't own the data center practically. You lease or you buy processing, you buy computer processing, you buy storage, you buy networks, you buy all that infrastructure with it. And also you can buy right to use of the services or the business application on top of it. So cloud comes into multiple, I'll jump to that one. Cloud comes into multiple models. The first one, which is really the one that we adopt, and we will look at that one as a maturity, really, that most of the companies will shift or lift their on-prem services or application into the cloud directly and still using their own traditional application on IaaS. And that's what we call the infrastructure as a service. So really using the infrastructure of the cloud as a service for you, but you're still putting your own application, your own needs in terms of business requirement on top of the IaaS. Then where you can move on a little bit into maturity, start really getting more use of the cloud capability, and it becomes more of a platform as a service for you. And this is really going into from an infrastructure, you start using an application underneath it, which can support you. And this is the case we found it mostly with companies who develop their own solutions, very customized, and they want to use the infrastructure and they want to use the capability. For example, they use the database available there, they use their development toolkits, they use the security, all that thing that are really supporting their own core, and then they can focus on developing their own applications. And we found this case a lot with for example, delivery companies or companies who are online services and they're expanding. So they have a very customized solution developed and they need to put it in the cloud because most of their customers are on the cloud. Most of the scale up that can happen over day, overnight, or seasons. So they need really to have a cloud so that they can allow that flexibility to them, which we'll talk about that flexibility later on in different models. And then when you have a specific business application that you need, they can be sitting in the cloud and you can use it as a service, use it as a software, as a service. For example, we have the CRM application, we have ERP applications, accounting applications, sitting on the cloud as a software available to as a user, and you can use it as a multi-tenancy, as a public for you, and you can share that applications with others, which allows you to reduce the cost and allows you also to avoid doing all that maintenance, all the upgrades. You just work on configuration which is specific to your own business needs, and also makes you focus on your own business needs, and you have your own IT people can shift and really focus on your specific requirement within that software sitting on the cloud. Now, we were saying, I'll go back to one slide here, which we skipped it very quickly, and that's important a little bit, is the hybrid. So why we talk about hybrid initially, there are multiple reasons, but there is one thing that happens through the maturities. No one goes to the cloud in one shot. No one goes in the cloud overnight. That doesn't happen really, except if you're really brand new company, brand new business model, that can happen. But most of the existing companies who are sitting on-prem with a data center, they do not go overnight. They go into in a journey. For example, let's say you have your CRM, your ERP, your business support system sitting on-prem. You cannot afford to go and ship them all. So what we do is maybe you will ship your CRM initially, and then you will ship your ERP system initially. So there is a study, there is a decision you have to make it. So you will find yourself during that transition period before you become fully cloud, you go into some on-prem and some on the cloud. And then you start becoming majority on the cloud. And then when you reach ultimate maturity, you become fully on the cloud. So you have to go through a transition. And we also have other cases where you have to stay hybrid. You have no choice. And we'll talk about that for some business requirement, for security reasons, for privacy data, and compliance reasons. We will talk about that more in details because that's part of the best practices, how we can manage on that, okay? So we talk about the different models we have, and then this cloud journey, which starts with readiness, for example, because we call it a journey, but sometimes we also call it maturity, meaning that you were in the prem. What you do is you start customizing, you start changing your on-prem made applications or infrastructure to be ready for the cloud, and then you shift it to the cloud. But in this situation, you're not fully making use of the cloud capability because your application are not really made for the cloud. They are sitting there physically. You are using the hardware, the infrastructure. You can slow down, you can minimize your data center, but your application are not really optimized. So what you go is you go in the next step, which is you start optimizing those applications and your infrastructure so that you can use more. For example, you have a CRM applications and it was using, for example, your security mechanism, like your LDAP sitting on the prem. So you move now your CRM and you change that and optimize it to start using your LDAP sitting on the cloud. So that's a movement. And then you move to the next third step, which is really, that's the ultimate, and that's really requires a lot of effort, a lot of training and knowledge, and also the right choice with the cloud provider, is your application becomes completely containerized microservices. And that means really fully utilized. This is your application is really made for the cloud completely with all the capability. There is something here we need to be careful about, and some people say it's born, for example, they use like cloud native or some /born native. That's a subjective discussion, that's subjective opinion. I would say there is no such a thing born native, because today we're still, so even though the cloud capability or the cloud computing is very advanced, most of the systems, the softwares are still legacy, really. They have not been born in native really yet. So they've been compliant, they have been converted, they have been adopted, but there are a lot of systems that we're still using on the cloud. They're not really born in native. So that's a subjective discussion really that can be going on. Now, another key thing before moving to that parallel, in the cloud, what's happening is you're making good use of two terms here. There is something called elasticity here in cloud, or computing elasticity, and the other term is called parallel running or parallel processing. Cloud elasticity, which is really comes from the term elastic, so that means you can, based on your demands, when your business is growing, for example, when you have more users, more customers, more data coming in, you can elastically grow the usage of the computing, of the storage, and the network and the security. And the same thing that if you go through seasons, for example, in the summer, your business booms and goes up, and then in the winter goes down. So that elasticity can make use of it when your applications are cloud native. The other thing is called parallel processing or cloud parallel native, which is really traditional again, but you have a much easier use of it in the cloud is when, for example, you have multiple processes, multiple transactions in a bank, for example, multiple transfers happening. What you can do is you process them in parallel, which allow you to process them faster, allows them to come back in a milliseconds, and you can handle multiple transactions on a second, and also allows you to have some kind of a failover for that. And one simple analogy or example we do that is when we see the traditional trucks, for example. Why we have trucks here, we see that they have 2 tires on a wheel. And this is really simple. It's doing the processing, multiple processing. When this tire goes flat, nothing happens. The truck will continue going. And that's really the idea or the concept of the parallel running or the parallel processing we have, okay? Now, let's go back again in terms of basics, talking about the traditional data warehouse. Traditional data warehouse, as we know it deals with structured data mostly. Yes, it did with unstructured, but really mostly it was made traditionally structured data. We extracted data, so we have a really practically ETL compared to an ELT. Maybe over time, data warehouse also did some conversion from ETL to ELT. So we are extracting the data, we're transforming the data, we can implement some quality rules, some validation, data enrichment, but mostly see the data is all coming from expected sources that are in-house. Sometimes they can be out of the house, but they still require. In the data warehouse, and traditionally, we know exactly what we are going to serve. So we are putting the data in specific data models with specific schemas, and we're trying to fulfill certain data march requirement based on the business, based on the stakeholders. And then we're making the data available for consumption or visualization, whether going through the OLAP or whatever tools they use for analysis, reporting, ad hoc reporting, dashboard, or even sometimes as an enrichment to other online systems or LTP system, like for example, you use the data warehouse to enrich the CRM about more analytics so that it will be available to the agent or to the commercials or the users of the CRM. So that's really the traditional data warehouse. And then what happens is we got the data lake came into the picture. And there is a discussion with data lake came to replace or to complement. That's ongoing. But let's see here really what really means data lake for the traditional data warehouse. So data lake, the reason why it came is because we wanted to lower the cost of the data warehouse because it becomes expensive and difficult to set up, and also because we got too much data coming in. Structured data, unstructured data, semi-structured data. So we needed to build a capability that can process this massive data at a lower cost. So data lake, in architecture-wise, it comes with zones, okay? And the only, I think, zone that really has to be there always is staging zone. All the ones are optional, really depends on how we design an architecture. So the landing zone is the data when it comes in, it lands in there when it comes from source systems, and it goes through some very preliminary, very initial cleaning, filtering, and aggregation, and then throw it into staging zone. And that cleaning, it's needed because you have some cases where the data requires that cleaning so that you can make an early detection about anomalies. For example, when you have multiple IoT devices, cameras, for example, sitting in a mall, and one of the IoTs is sending you very, very low data, not expected. So you can detect that in landing zone, and you can take some action on that. And then you have the staging zone where you get that clean data filtered preliminary, and also can have data coming from source directly into staging zone if the data is already clean or structured or aggregated into staging zone. And then you have the analytics sandbox, which is another zone. This is really purely used for data science, for data experimentation, data exploration, data discovery. And this is not really for business use. It's used by data scientists practically, and they can combine that data with a data warehouse. Here you see how the data lake and the traditional data warehouse can coexist together and can be complementing to each other. So you can do algorithm application, you can do some mathematicals and do some discovery on the data. And then we have this curated data zone, and this is where the discussion can happen. Is this part of the data warehouse, part of the data lake? It depends how you're looking at that. When they say it's part of traditional data warehouse, it's because it has curated data, clean data, traditional data. But there is another discussion saying no, because it has also big data in it. So to compromise between the two, it's called big data warehouse, really, which is, again, part of data lake or can be part of the traditional. So this is what we have in traditional. Now, data lake came in because we needed to help us to process more data at a lower cost and make it easier for us. But still, again, we found ourselves that still the data lake on-prem in a traditional way, not capable to handle what we need because of the explosion we have the data. This explosion we had, and it showed us the limitation of the traditional data warehouse and also the limitation of the traditional data lake. So these limitations also brought us some opportunities. Limitations, what we're talking about, explosion data and generated. The data is generated, some statistics say it's doubling in terms of size on a yearly basis. So that's huge. And where is data is coming from? It's coming from users who are consuming it and also who are generating it. Users like you and me, who are like, for example, we have a Fitbit, we have a smartwatch, a smartphone, our IoTs in our houses, IoTs in malls, cameras, IoT in phone, or IoT in cars and devices, IoTs in gates. So that's all is really generating the data. So there are users generating it. And those users also, they are sophisticated. So we talk about business users, we talk about dashboards, through KPIs, we also talk about data scientist users. So there is a new type of users with sophisticated requirements. New data types, of course, as we said, structured data is not anymore the standard here. We talk about non-started, we talk about source systems coming from social media, with PDFs, emails, chats, ratings, all that is happening. That's all new data, which is bringing a new challenge to us. And then, data is not always necessarily on-prem. It's always not coming from a CRM or a BSES or some kind of billing system. It's also coming from the cloud, coming from social media, like we're talking about, coming from the delivery companies, coming from Facebook, coming from IoTs, coming from the street. So the data is really out there in the cloud. So it really makes sense to go to that data and still process it and load it into the cloud. And then we have the other challenge or the other limitation that showed up with the traditional data warehouse and data lake is we need to support AI and machine learning and IoT. So because AI and machine learning is using this data in a massive way, and it needs really a lot of big volume so that it makes sense and gets really reliable algorithm out of it and reliable models out of it. But also this AI will feed back the data analytics as a source to it. So that gives it that limitation and that another opportunity for us while we're moving to the cloud. Now, we move to the cloud. Does the cloud solve all the problems? No, it does solve many problems. It does solve some problems, but we still have some challenges with the cloud. So it does help us to optimize the cost. As we said, data warehouse and data lake. Data warehouse specifically was quite costly to maintain, quite expensive to maintain. When we move into the cloud, it gives us that optimization based on the usage. We can have a model that fits our strategy. I can have a model that fits our needs. For example, we can start pay as you go model because we're not really sure how the volume will be needing it, and we will be paying based on usage. And then when we grow and we have more maturity and we know exactly the volumes of the data we have and we know the complexity of the process we want to do in the data analytics, then we can go and adopt a model that is more stable and we can lock into a certain model that gives us cheaper or a lower cost. Also, we are completely getting rid of the CapEx here because we don't own the data center, we don't own the hardware, we don't own the infrastructure around it. So that's all leased. So it is not anymore part of the CapEx. Agility. The cloud gives us that flexibility really to work in a flexible way and an agile way. Meaning that I can change my strategy, I can change my view, I can change my methodology without having a revolution, without having really to throw out hardwares or having to change the skills of the resources I have within the team. So that's really important. Scale. So we were talking about elasticity. We can scale up, we can scale down based on the season, based on the growth of the business. And that cloud gives me that flexibility to go in. But again, too much flexibility can make it expensive. So it's really important to start with as flexible as possible. But then over time, when the maturity, when vision is really clear and the needs are very clear, it's important to go to a lockdown model so that we can lower the cost. Management. When I'm sitting on the need to manage the hardware. I don't need to manage the access to the data center. I don't need to manage the security. I don't need to manage the upgrade. I don't need to manage the obsolete. I don't need to manage the patches, the bugs. All that is taken away from me as a business user when my applications are sitting on the cloud. Serverless. This is really practically is the future of the cloud. The containerization, that's really, really important, and it's a big capability that will help us to the cloud to resolve the issue. Consumption pricing, which is back to the number point one, customization, is I can use an ad hoc or a price as you go model, which allows me to use based on the price model I put in. So if I consume more computing, more storage, I will pay for that. And if I use less, I will have a scale down and I will have a less cost. But again, we need to be careful on this modeling. Again, we need to quickly understand the optimization. We need to quickly understand the usage that we will have on the cloud so that we can lock down and go in a more stable mode. Now, going back to the core of our subject here, which is the best practice when we're going cloud for data warehouse and data lake. The very first important thing, and I think this is really still valid in the case of traditional data warehouse, but it becomes even more important when we go into the cloud, is we need to have a full alignment. We need to have a full alignment with the business in terms of requirement, in terms of data they want to access, data analytics requirement they have on it. Because that misalignment can really can take us in the wrong directions in terms of the deliveries. And this is why it is more challenging in the cloud, because as we said, the data is really sitting outside the organization most of the time, and we talk about a very high percentage. Sometimes we have 90% of the data that comes into your cloud data warehouse is coming from outside the organization, from source providers that that links it into your data warehouse or data lake. And this data can be misunderstood, can be, for example, have a different definition. And we have the cases where we use the same word to mean different things, and sometimes we mean different things using the same word. So it's very important to push for a common understanding of the data. And a key word in this situation, for example, we have to have a glossary, we have to have a data dictionary, we have to have a data profiling. It's important to have that alignment between technology team and business users, business consumers, whether they are data analysts or data scientists. Now, another best practice is to define the data flow within your cloud data warehouse, your data lake. And that's, again, it's important to understand where the data is coming from and how it is being transformed, and how is it going to be used, how is it being calculated, how is it being concatenated, how is it being filtered. And a key word for that is the data lineage, practically. Because we will not be able to deliver specific reports or deliver specific model to the data scientists or the data consumptions or data visualization tools if we don't know exactly how the data is flowing properly, so that we can control and can validate and can do check marks on that. Another thing is stay as much as you can agnostic to your systems, because they change. They can change in terms of volumes, they can change in technology, they can change in terms of availability, in terms of data quality. So you need to safeguard yourself and your architecture when it's built in a standard way that will not make you too much dependent on the source systems. You need to be very agnostic to that. Another thing is you need to adopt standard architecture as much as possible. It doesn't matter which standard, it doesn't matter which one the best one, but you need to have one standard throughout the organization and the enterprise, because that will allow you first to simply adopt to new technologies or new concepts and new trends, and also to allow the team internally to be able to understand that, whether they are new members or existing members, to have a full common language in terms of architecture that's being built around the data analytics on the cloud. Another thing it's important, as we see this very, very often, we have to adopt agile methodology in terms of delivery. You cannot have a data warehouse on the cloud or data lake or even traditional going over 8 or 10 or 12 months project. That's too heavy, too long, and it doesn't show the quick wins. The second thing is important why you have the agile methodology. The requirement will change. Business requirement will change over time. They can change over a month or 2 months, 3 months. So the first cannot be 6 months. You will be working on an obsolete requirement. And you have to adopt and you have to really support those business requirements, and you have to support the changing priorities of the business. So it's not anymore a luxury. It's not an add-on. It is a must that the delivery has to be agile and has to match the business changes.
Hafdi, we are short on time. Unfortunately, we've already taken a little more than what we're supposed to. Please, we have to wrap it up.
Yeah, no problem. Yeah, very quickly. So ETL, LTL, it's really important. We have to adopt ELT instead of ETL because number one for data warehousing on the cloud is bring the data. Number one is really bring the data. And then once you have the data centralized in one place, you go and process it. The last one, number 7, is automate as much as possible. It's very, very important to automate all the processing as much as possible. And the other one is the staff. You need to really make sure that your staff is modern on practices, is well trained, so they understand the trend, they understand the methodology, and using the latest technology. And the other one is, as we were talking about, is pick the most flexible cloud providers. Very, very important because it also adopt that. Another really last thing is about the security, because we talk about public sector, we talk about banks here. Data privacy and security is very important, and this is where we find most of the organization, they have to adopt a hybrid cloud, meaning that there's some of their data has to sit on-prem. They have no choice, and some other data can go on the cloud. So they have to go in this complex situations, and this is really important for them. So they have to have the right architecture, right technology, where they can combine between the two locations, and they have to live in the hybrid. Another thing is you have to align with the procurement process, because we talk about agility, pay as you go, and flexibility in that. Sometimes the procurement is not really aligned with that. So you need to work with a procurement so that you can align and see how that can be changed, so that you can support each other on that. Nizam?
Excellent. Well, thank you very, very much, Mr. Hafdi. That was a great session. We know that we've got a couple of questions now. Unfortunately, we're very, very, very short on time. We don't have the time to take the question. However, Mr. Hafdi, what we'll do is we'll get the delegates who's asked the question. We'll connect those delegates who asked those questions with you directly via email. So we've asked our colleagues to send an email and connect you with them so we can answer those questions. So ladies and gentlemen, if you have